Hello everyone, I am Aishwarya and today we will be discussing about the matter and its classification. In the previous video, we have already learnt about what is meant by matter and what are its states. If you haven't seen the video, you can watch it by the link given in the description. Fine. Now let us start with the matter and its classifications. We know that everything or anything that we see around us is known as a matter. If that is so, we can classify it in different ways. Now we are going to classify this matter by physical classification and by chemical classification. And when it comes to physical classification, we come across solids, liquids, gas, and plasma. And these four are also known as the states of matter. And these are being discussed in the previous video. And in this video, we'll be discussing about the chemical classification of matter. That is, the matter can be classified chemically into two types. That is, one is mixture and the other is pure substances. Now, let us know what is meant by mixture. A species or a chemical species formed by the physical combination of two or more substances is called as a mixture. That is, any two or more substances made in physical combination will give us a mixture, right? There is no chemical bonding between the substances. There is only physical combination of two or more substances, and that will give us a mixture. Let us take an example of a sugar and a water. When you put the sugar into the water, the sugar gets dissolved in the water. It will not be there will not be any chemical contact between the sugar and the water. That is, there is no formation of any chemical bond between the sugar and the water. Instead, the sugar just changes its physical state. From solid it is becoming liquid. That is, it is combining with the water. Only the state of it is being changed. So they are only in physical combination with each other. And the composition of the sugar and the water both are retained in the mixture. They will not be changed. On further heating the sugar solution, we will get a solid crude sugar. So, what we can say finally is that a mixture is just a physical combination of two or more substances. Apart from this, what we can say is that in a mixture there will not be any physical chemical combination. Instead, there will only be physical combination. So what we can do is that we can retain or regain the characteristics or compositions of the components of the mixture. Here a sugar solution is a mixture. Sugar and water are the components of the sugar solution mixture, right? Now let us see the classification of this mixture. That is, one is homogeneous mixture and the other is heterogeneous mixture. Why we will classify the mixture into two types is that, as we know that it is a physical combination, and that physical combination can occur in two types, that is uniform form and ununiform form. This uniform combination of two or more substances is known as homogeneous mixture, or else a mixture containing the components uniformly in its body are known as homogeneous mixture. Then can we say the sugar and the water, or else the sugar solution as a homogeneous mixture? Yes, we can say the sugar solution as a homogeneous mixture, because here both sugar and water are in uniform throughout the body. That is, their composition is uniform throughout the body. Then let us take another example of water. Water consists of hydrogen atoms and oxygen atoms, and these are uniform. That is, their ratio is being fixed. Two molecules of hydrogen and one molecule of oxygen will give us a water. Means there is need of only two hydrogen atoms and one oxygen atom. This ratio, that is 2 is to 1 ratio, is being fixed. That is, their composition is fixed to form a one molecule of water. Then coming towards diamond, which is also the allotrope of carbon, consists of two or more kinds of carbon atoms within it, and that composition is also fixed. Then coming towards the heterogeneous mixture, a mixture whose composition is not uniform throughout its body. The best example for this is the mixture of oil and water. Take a cup of oil and take a cup of water and put some oil in it. You will not find the complete mixing of oil into the water, because there is another layer of oil at the upper side and water at the lower side. This means that few droplets of oil are being present in water, few droplets of water are being present in oil layer, but they are not thoroughly mixed. So this is non-uniform or ununiform uh, composition of the components of mixture. So we say it as a heterogeneous mixture. An example can also be of sand and water. That is a mixture of sand and water. The droplets of water can either be in water also, and sand can float in water. There is a clear boundary for the separation of the components. When it comes to homogeneous mixture, we do not find any of the boundaries here, that is separation of layers. But when it comes to the heterogeneous mixture, we can see a clear cut boundary for the separation of the mixture. As like that of in organic chemistry, we can find while separating the compounds, two components, which one is polar and the other is non-polar. We see one as an aqueous layer and another as an organic layer, and that is also known as a heterogeneous mixture. Then this is all about the mixture, and now let us see about the other type of chemical classification, that is pure substance. These are made up of one type of an element or a molecule or a compound. What this is that they can either be one kind of an element, one kind of a molecule, or one kind of a compound. That is, pure substances are not the mixtures. Their composition of substances is fixed. Likewise, take an example of hydrogen element. Take it as an element, not as an atom. Take it as an element. Hydrogen atom is made up of similar kinds of atoms of that element. That is, similar atoms makes up a atom, one element. So that atoms consist of same atomic numbers, and that same atomic number atoms makes up an element. And so similar atoms will give us an element. It is known as a pure substance because there is no mixture of any other substances or any other atoms. When it comes to a molecule, now take one hydrogen element and the other hydrogen element. Now we are going to combine these chemically, and this chemical combination will give us the molecule, that is hydrogen molecule. We write it as H2. So here hydrogen and hydrogen both are of similar kind, they are combining, so it is a pure substance. When it comes to a compound, glucose is known as a compound, right? Let us take an example of glucose itself. It consists of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Here 6 carbon atoms are having same properties, 12 hydrogen atoms are also having same properties, and 6 oxygen atoms are also having the same properties, and these three are combining together with a fixed ratio. So it is forming a compound, and also this is a pure substances. Pure substances are of two types, elements and compounds. That is, we are going to classify the pure substances into two types. One is an element and the other is a compound. When it comes to an element, we say that the similar atoms makes up an element. Here, take an example of simple hydrogen element. We write it as H, which is represented as 1H1, right? That is, hydrogen element is formed by the combination of similar kinds of atoms. So similar kinds of atoms will give us an element. Element is a basic form of matter and which cannot be broken down into smaller substances by chemical reaction. Take an example of hydrogen molecule. Hydrogen molecule we represent by H2. On chemical reaction, we can break into H and H. H2 can be break down into H and H. And here we are breaking a molecule into an element. So this element on further chemical reaction will not give us a simpler substances. So the simplest form of a substance is known as an element, we can say. Then this element can be classified into metals, non-metals and metalloids. As we know that metals are lustrous, sonorous, malleable, ductile. That is, they can be beaten into thin sheets. When beaten, they give us the sound. So they are known as metals, and also they are the good conductors of electricity. And the best examples for metals is that all the elements that are present in S, D and F block are known as the metals. Only exception in S block is that hydrogen is not a metal. Right. All the elements that are present in S, D and F block are known as the metals, and some elements from P block are also metals. Then non-metals. These on beaten will not give any sound, and these are also malleable, that is, they can be beaten into sheets, but these are poor conductors of electricity. Then, what are the examples for non-metals? Non-metals are the P block elements. The P block elements are known as the non-metals, but there are few elements which are not non-metals in that P block, that are boron, germanium, antimony, tellurium, and arsenic. These are not the non-metals. Instead, they are the only metalloids present in the periodic table. Which are those? Boron, arsenic, tellurium, antimony, and germanium are the only metalloids present in the periodic table. This is about the classification of element into metals, non-metals and metalloids. Now let us see the second classification, that is compound. What is meant by compound? Compound is a substance which is composed of two or more chemically combined together in a fixed ratio. We said glucose is a compound acid. Right. What we can see there, the carbon, hydrogen and oxygen atoms are being chemically bound to each other with a fixed ratio. There can only be 6 carbons, there can only be 12 hydrogens, there can only be 6 oxygens to form one molecule of glucose. So what we can say finally is that there is a fixed ratio to form a compound, and that fixed ratio consists of either similar or different kind of atoms. There is no rule that there should be only similar kind. No, they can be similar or they can be different atoms which are chemically combined to form a compound. Let us take an example of water. We can also say water as a molecule also and a compound also, because water is formed by two types of atoms, that is, one is hydrogen atom and the oxygen atoms. There are two different atoms in it. Fine. Then see their composition. Two hydrogen atoms and one oxygen atom. This 2:1 ratio is fixed, and so it is forming a water as a compound. Carbon dioxide, where one carbon atom and two oxygen atoms which are of different kind are combining chemically to form a carbon dioxide. So it is also known as compound. Sugar, sugar in the sense glucose. Glucose means C6H12O6. Salt, NaCl, sodium and chlorine. Many more examples will come as we go on seeing the examples for compound also and for element also. Now let us see the main differences between the element and the compound, because most of the times we come across a difficulty that which should be said as an element and which should be said as a compound, or which should be said as a molecule. So let us see the differences between the element and the compound. When it comes to element, it is a pure chemical substance. There is a chemical bond between the two atoms but they are of similar kind. So what we can say, two or more atoms of similar kind will give us an element, right? But when it comes to compound, two or more kind of an atoms which are different and are undergoing chemical combination will give us a compound. That is, a compound contains many elements in it, and those elements can be different also, can be same. If they are same, it is known as an element. If they are different, it is known as a compound. So finally what we can say, element is just the combination of two or more similar kind of atoms. Compound is that chemical species formed by the chemical combination of two or more different atoms is known as a compound. Element contains only one kind of atoms. Compound contains more than one kind of atoms. It cannot be broken down into similar substances. That is, element cannot be broken down into simpler substances, but the compound can be broken down into simpler substances. That is, when you go on heating sugar, you get different carbon atoms, we get different hydrogen atoms, different oxygen atoms. That is, carbon, hydrogen and oxygen can be separated separately from the sugar. So we can simplify, or we can get simpler substances from compounds, but not from elements. Only 118 elements are known in the universe. We know only 118 elements, and that are being seen in the modern periodic table that we study every time. But when it comes to compound, there are as much as many compounds. It is based on us what we are going to. If I combine any of the two elements, that forms a compound. If I take other elements and I go on combining different atoms or elements, I will go on forming different compounds. So there is no restriction of only such many, so many, little many compounds are present in universe. There are as much as amount of compounds possible on the universe. These are represented by symbols. That is, elements have a definite symbol. That is, we represent hydrogen element as H, carbon as C, and oxygen as O, chlorine as Cl. But there is no representation for a compound. These are represented by unique formula. We have a different formula. That is, C6H12O6 is not a symbol for sugar or glucose. It is just the unique formula of sugar. In order to represent the formula, we take C6H12O6. That is, their composition is being taken with their fixed ratio in order to form a formula. So these compounds do not have any of the symbols, but they have the formula. There is different types of chemical bonding depending on stability and electronic configurations. Based on the stability and electronic configuration, we can find different types of bonds within the elements. Ionic bond, covalent bond, hydrogen bond. Likewise, different bonds can be found in elements. But when it comes to compound, we also find these bonds. We can also find the covalent bonds, ionic bonds, hydrogen bonds within the compound. This is the similarity between the element and the compound. Now let us see the examples for element and for the compound. Hydrogen, oxygen, sulfur, and all the elements present in periodic table are the examples of element. And water, sodium chloride, sulfuric acid, glucose, or any other compounds that you know are the examples of compound. This is the main difference between an element and the compound. And now we are clear that what is meant by an element, what is meant by a compound. Atoms of similar kind will give us an element. Atoms of different kind will give us a compound. So finalizing this, what we can learn is that we found a new terms within it. That is, ionic bond, covalent bond, or different types of bonds between the atoms, or between the molecules, or between the elements. So in the next video we will be learning about the types of bonds that makes up a molecule, or that makes up a compound. If you feel good of this video, please do comment and give me some suggestions. Thank you.